Okay, let's dive right into this fascinating research, because it completely flips the script on how we build applications with large language models. If you've been following the AI space, you know we're absolutely obsessed with making single models bigger, faster, and just better. But researchers at Microsoft took a totally different route. They asked a brilliant question. What if we just made them talk to each other? Welcome to our explainer lesson on AutoGen.
So we've all been there, right? You ask a single AI to do something super complex, write a script, run it, check for errors, and it either totally hallucinates or just gets stuck in an endless loop. Which brings us to a really surprising, very real-world problem. How exactly do we push past the ceiling of a lone AI's capabilities without just, sitting around waiting for the next massive model to finish training?
Honestly, think of it like a lone worker versus an elite team of specialists. A single AI model trying to do everything is kind of a jack of all trades. It tries to brainstorm, code, execute, and QA all by itself, and it usually fumbles. But a collaborative team of AI specialists, they can debate, they can fact-check, and they can safely execute complex code together. If one agent slips up, another agent is right there to catch it.
Here's our game plan for today. We'll start with the single agent problem, explore the AutoGen chat framework, look at some real-world examples, unpack the actual results, weigh the impact against the limitations, and finally, wrap up with our key takeaways. Let's get to it. Starting with part 1, hitting that intelligence ceiling with single agents. When a solo LLM tackles complex math or coding, it literally hits a wall. It lacks divergent thinking, meaning it pretty much only follows one single train of thought at a time. It really struggles to double-check its own reasoning. And it has a notoriously hard time breaking down massive, complex tasks into bite-sized subtasks. When you ask it to execute step by step, it just loses the thread.
Which leads us perfectly into part 2, AutoGen and the conversational workforce.
Before we get bogged down in the technical weeds, let's break this down to basics. Think of a conversational agent as basically just a teammate in a group chat. It has a very specific job description. It can message other agents, it can run a calculator or a Python script, or it can even ping a human, like you, when it's confused and needs a little direction.
Imagine a setup where these distinct agents actually collaborate. You might have an AI assistant that writes code and a totally separate user proxy agent whose only job is to run it. The assistant shoots over some Python code to plot a stock chart, the proxy runs it, realizes a software package is missing, and messages the error back. The assistant apologizes, writes the install command, and they work it out, literally just like two devs slacking each other.
To make this magic happen smoothly, the researchers invented something they call conversation programming. It sounds super intimidating, but all it really means is that the rules of the group chat dictate how the whole software program executes. Instead of writing one massive, rigid block of code to predict every single error, you just set the ground rules for how these agents are allowed to converse. It flows beautifully. It's a very clean input, process, output loop. Step 1, your initial prompt kicks things off. Step 2, the agents start firing off automated replies, executing tools, and checking each other's work. Step 3, they just keep going until they hit a specific finish line, like successfully generating that chart, and then boom, you get your final solution.
Setting up an auto-reply mechanism under the hood creates a completely decentralized workflow that practically runs itself. Actually, there isn't some central boss script micromanaging every single step. The agents just react to each other's messages natively until the job is fully done.
Okay, moving to part 3. Let's see these virtual teams in action with some real-world examples.
You can structure these conversations in some incredibly clever ways. For instance, you could have a student AI consulting an expert AI whenever it gets stuck on a tough problem. Or you can go even wilder with a dynamic group chat. A manager AI looks at the task, looks at everyone's roles, like a coder, a reviewer, an executor, and dynamically decides who needs to speak next. It's literally a virtual conference room.
Let's apply this to a text-based household simulation called AlfWorld. Traditionally, a solo agent trying to navigate this game kept forgetting it had to actually pick up an object before examining it. It would try to examine a vase from across the room, fail, and just get permanently stuck in an infinite error loop. AutoGen elegantly solved this by adding a grounding agent. This agent's entire purpose is to yell out common-sense physical rules into the chat the second it sees the team getting stuck.
Now, for part 4, let's unpack the results and translate these metrics into plain English.
When put up against the absolute hardest Level 5 math problems out there, Auto agents working together achieved a 52.5% success rate right out of the box. That beats premium single-agent tools like ChatGPT with a code interpreter, and it absolutely crushes other single-agent frameworks like LangChain React. Teamwork literally makes the AI smarter.
And what about safety? That's a huge factor. In a supply chain coding environment called OptiGuide, they pitted a solo agent against a full AutoGen team. This squad had a commander taking orders, a writer writing the code, and a dedicated adversarial safeguard agent whose sole existence was just to be the bad cop and hunt for security risks before the commander ran anything.
That multi-agent design didn't just give a tiny bump to code safety, it drastically boosted the system's ability to identify malicious code by a massive 35% when using GPT 3.5. By giving one single agent the explicit job of being the bad cop, the whole system becomes incredibly robust.
Furthermore, remember that AlfWorld decision-making task with the virtual household? Introducing that common-sense grounding agent brought an average 15% performance gain across the board, completely eliminating those endless error loops. Just dropping a single specialized agent into the chat instantly upgraded what the system could do.
Part 5, the impact, and of course, the limitations. We have to look fairly at both.
On the positive side, AutoGen allowed developers to shrink complex workflow code from over 400 lines down to just 100. It's super modular, and since each agent has its own isolated memory, they don't hallucinate or get confused nearly as much as a single model doing a juggling act. But the authors are very clear about the risks. Giving automated AI the power to write and run code on your machine could lead to dangerous unintended consequences, like accidentally deleting your files if you don't build strict safeguards into the chat. Plus, if you add too many agents to the mix, you run the risk of them just getting trapped in endless, unintelligible chatter.
Finally, Part 6, our summary and key takeaways for this lesson.
So here's the bottom line you need to remember. Single AIs hit a hard ceiling on reasoning and validation. Microsoft's brilliant solution, AutoGen, shatters that ceiling by treating complex programming as a multi-agent group chat governed by conversational rules. The results are undeniable. Massive gains in math, safety, and physical reasoning. Ultimately, AutoGen proves the future of AI isn't about training one massive, omnipotent brain, it's about building highly structured, conversational teams of specialists that hold each other accountable. Which leaves us with one final, very provocative thought to chew on. When your software framework can effortlessly spin up an entire virtual company, complete with a manager, a coder, and a safety reviewer, to solve a problem in seconds, where exactly do you fit into the org chart?